Hello everyone, this is Kent Jarrow here for Fundamentals of Physics. My instructor is Raul Vargas, and I'm going to be explaining to you today how Newton's three laws of motion pertain to the game design program. Well, let's get started. Newton's first law is the law of inertia, which states that an object at rest tends to stay at rest unless it's acted upon by an outside force. Newton's second law is more of an equation than anything else. It states that force equals mass times acceleration. Now on to Newton's third law, which states that for every action there is an equal and opposite reaction. Now as it pertains to game design, I'm going to talk a little bit about how when we create video games, there are certain things that players want to see in video games that they see in the real world, hence realism. Shown here is a picture of the Amazing Spider-Man 2 video game, where Spider-Man is jumping. Now, as a player, when I have a character that jumps off of a building, I expect that character to fall. And I expect that character to fall because of Newton's first law of motion. The outside force being gravity pushing the character down, and the action being jumping off to a point where there's no solid ground underneath. Now, we'll move on to the second portion. Shown here is a picture of Forza Motorsport 5, a cockpit view. In this video game, there are a lot of different aspects that the game designers need to be aware of in order to make the game as realistic as possible. As a racing simulator, players want to be able to play the game and just feel like they're absolutely immersed in a race in real life. And this pertains to Newton's second law, which is force equals mass times acceleration. And the game designers need to be cognizant of this when they try to create these racing simulators. Can anybody tell me what this is? If you haven't, then you really haven't played video games. But shown here is a picture of a super jump. And this is done by players in Halo 2, the video game. The players find a glitch in the map, and they jump into this glitch from a higher place. And this pertains to Newton's third law, which is for every action there's an equal and opposite reaction. And when the player jumps into this glitch, it launches them sky high. Now here I have a short video that I'd like to show you that implements Newton's third law. Now, I'm going to demonstrate Newton's third law of motion, which states that for every reaction there is an equal and opposite reaction. And I'm going to do this using one plastic bottle. Only one plastic bottle. Now the plastic bottle already has air in it, but when I twist it, like so, I build up the air pressure in the top portion of the bottle, like this. And after building up all that air pressure, it only wants to release. So when I loosen the cap, like so, the top cap shoots off, and there's the air pressure escaping, which is the opposite reaction to creating all that air pressure. And that is an example, ladies and gentlemen, of Newton's third law of motion. For every reaction, there's an equal and opposite reaction. Thank you. Now, it's up to us as game designers to know when to use Newton's laws and when to not use Newton's laws, because not all games need to use Newton's laws, but it's up to us to be able to put them and implement them in a way that's going to both excite players and help players understand what's going on in the game. Well, thank you. That's all the time I have for now, and here are my image citations.